Alright, so if I have a population of rabbits, and when it was first counted, there were 100 rabbits in the field, and 1 year later, we counted again, and there were 140. Now, if the rabbit population is growing according to a linear model, that means you add the same amount at every transition. So if I made a little table, n and p sub n, at time 0 we had 100 rabbits, year 1 we had 140 rabbits, and because I know that this is linear, because it's given in the question, I know that I am growing by adding the same amount each year. So my next set of rabbits would be 180, and then 220, etc. So if I wanted to write an equation to represent this sequence, if I did a recursive one, I would say, well, p sub n should be equal to p sub n minus 1, that is the population from the previous year, plus 40 more rabbits. And if I wanted to do an explicit equation, that would be p sub n is equal to, well, how many I started with, 100, and then I add 40 over and over and over again, n times. So I do plus 40n. So that's my recursive and my explicit formula, based on the table I made. And then according to this model, P10, the easiest way to calculate it would be to use the explicit formula, because I know P sub n is 100 plus 40n. So P sub 10 should be 100 plus 40 times 10, which is 500 rabbits. But you could also come up with 500 by continuing the table that we started right here. So now, if we assume that the population grows exponentially, this is going to be an entirely new table. So I'm going to make an n p sub n table for this exponential growth. So I know that at time 0 there were 100 rabbits, and at year 1 there were 140 rabbits. But now, because this is exponential growth, that means that the rule I use to transition from one year to the next is that I multiply by the same amount. So I have to ask myself, to get from 100 to 140, what did I multiply by? So I can figure it out by doing 140 divided by 100, and I get 1.4. So then I continue using that multiplier to get from one year to the next. So 140 times 1.4 is 196. And 196 times 1.4 is 274.4, etc. Okay, I can keep going on like that. And if I want to write a recursive model for this, I would say, well, the population at any year n is equal to the population the year before, which we denote p sub n minus 1, times 1.4. And my explicit equation would say, well, I'm starting with 100 rabbits, and I'm multiplying that by 1.4 over and over again. And how many times? N times. And to multiply by 1.4 times 1.4 times 1.4 n times, we write that as 1.4 to the n. So these are my two equations, a recursive and an explicit, for the exponential growth. Now, if I want to figure out P10 based on the exponential growth model, again, the easiest way would be to use the explicit formula, 100 times 1.4 to the 10th, or to the n, and then I'm going to replace the n with a 10. 100 times 1.4 to the 10 is 2,892.5 rabbits, and I'm just going to round it to 2,893 rabbits after 10 years.